Hello and welcome to the Extended Greg YouTube channel. I'm Greg, and on today's show we're going to be building a robotic camera pan tilt control. So pretty much it's going to be using some servos and a Pi Pico as the actual brain of the device to be able to interpret joystick controls and be able to move the servos appropriately. The idea behind this is repeatability, as well as making very smooth and precise movements to be able to make some good videos. So we're going to be building this pseudo from scratch. Some of the things are kits, but it's pretty bare bones. So let's get into it. We're about to get extended. All right, so pretty much what we have here are keyboards. That doesn't help us. We have this. So this is a pan tilt zoom kit from Amazon that I just got. And it's 2DOF, which stands for 2 degrees of freedom. And pretty much what we're going to do is do a quick assembly on this. It has a few servos. It has some bearings and control boards. And then it has some other plates that are pre-machined to be able to do it, and a bearing for everything to ride on. But as far as the logic, everything else like that, that's all going to be on us. I'm going to turn up the exposure here a little bit. Let's see. Boom, 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 boom. So pretty much, let's just open a few boxes really quick. So I'm going to unpack the rest of this. And what we have here are two different servos, but they're both waterproof. And the idea behind what I'm doing is I'm actually going to try and make this so it's water rated. So that way I can take it outside in the rain and be able to shoot some really nice scenic overlooks, things of that nature, without having to worry about water infiltration destroying the rig. So especially for things like hiking, etc., you know, you don't necessarily want to have to hike all that way, hike all the way back with something that doesn't work, and then try and go back and do it again. So this is a 20 kilogram centimeter servo, and we're going to use this as the pan servo, and they're very tiny. And it does come with all of these accessories, although I believe that's a default. We're not actually going to use these because these are plastic. So pretty much everything that we're going to be using on here is metal. And even internally to this particular hermetically sealed servo are metal gears. I haven't opened it up and checked, but that's what it advertises. So it should actually have quite a bit of longevity. And let's open up the other servo as well. Same kind of deal. This one is 25 kilograms per centimeter. And the reason for that is this is going to be used as the tilt motor. And the way the tilt mechanism actually works is it doesn't actually respect center of gravity or anything else like that to be able to compensate for a weak motor. It just kind of powers through it. So we're going to see how that works. Hopefully this is high enough capacity to be able to actually use it for this application. But I don't think the camera is going to be that heavy. And realistically, this kit is actually to be able to pretty much use it for an arm, a robotic arm. So you'd use it as the base, you'd use it to be able to spin and everything else like that, and then tilt down, and then you'd add additional motors and actuators and things like that, and it would be theoretically able to do useful work. So as far as everything goes, it should be more than enough to be able to suit our needs. But again, we're going to find out when we try it. So I'll unpackage these right here, which are the metal plates. And these are actually pretty nice. They're anodized green, aluminum. And let's see. So the servo, 20 kilogram servo is going to mount there. We have some rotation rings that will also hold the bearing on the outer race and provide the mount to here. So you kind of see how this is just going to stack up like a bunch of wafers. And then this will actually ride on top. On top of that, we'll have the other servo. And then we have this carrier right here. And what this is it has the drive mechanism, and this is a universal interconnect. It's a splined shaft on the actual servo itself, and you just tighten down a screw on top of it, press it in, and it actually makes a very good mechanical connection. And then there's a small bearing in here because it's going to be a fork. So it's a yoke technically, but what we have are 2 additional aluminum plates here. One of them is this. So the camera will sit up here, and this will rotate around in order to get the pan, and it will sit on top of these platens in order to get the, the pan, and this will do the tilt. And then it has this, which will actually mount the servo like so, but provide a place for the bearing to actually attach. So that way it's not just cantilever, it's actually evenly supported, which should hopefully help in stability and prevent things like shake. So we have hardware as well in this bag, right? So we have a bunch of standoffs. We have another kit, and this has the actual receiver for, or actually no, this is just another one. So hopefully it did come with all the components. I'm going to say that because I don't actually know. There was no way for me to be able to audit that, but I think it did. And that being said, I don't know that it actually came with any instructions because I didn't see any, but I will double check the box. And the answer is no. So I don't see any instructions with this. Maybe it's supposed to, I don't have them. So we're just gonna make it up. So this is the bearing. I'm not gonna take it out because it's gonna get everything greasy. And it's not a sealed bearing, so yeah, when it gets wet, it could degrade over time. But it is a deep groove ball bearing, and that means it can handle more lateral forces, and in general, this is actually rated for much higher than we need. So we'll stay within the tolerances, even though it's not a thrust bearing per se. It should be able to handle the lateral loads that we're putting on it without causing damage to the bearing. So let me see if I could pull up a reference really quick. And what's going to be is oh, I'm not even logged in. Let's see. But what it's going to be is pretty much a quick assembly. I just don't know where the actual things would go. So let's see if we could just find this really quick. All right, so this is what I actually got. So we can kind of see how it fits together. Let's actually make this bigger. That doesn't seem better. All right, but you can kind of see it. So we have the plate, we have the platen, everything else like that. Let's see if we have assembly instructions. We just kind of see generally what it is. So this will actually be helpful because it does show us offsets, things of that nature, measurements. And we can just visually see how it actually fits together. But you can see it's more universal in terms of whatever you want to actually put there. So let's put the keyboard away. I'm going to just keep popping back and forth to be able to do that. So first thing we're going to do, I don't know if this is the correct order or not. We're going to build our base. Okay, and I don't see that there's a top or a bottom, but we do know that the 20 kilogram per centimeter servo does go into it. And I do want to see if I can find a better angle. Yes, it does go on top. All right, so let's start with our first kit, which I assume is the one that doesn't have the bearing, because the bearing would be for the tilt. So we'll start working off of this kit. Hopefully it's right. Organize a few things really quick. Thankfully, all of these are pretty much the same size, so we do see some washers, things of that nature. It does look like these will receive washers, just based on the images. And also because it's an open hole, so the washers will just fit right there as we're actually putting them in. And where's my screwdriver? There it is. I use a micro driver, so it's a little easier to see, but it looks like it actually would accept a number 2 Phillips. So I'm going to snug it up, but just not tighten it all the way so we can get everything aligned before we actually do tighten it all the way down. So we'll take our next screw, put in the washer, and I'm going to do it diagonal, just because I like the way that aligns it. Try and center it up as much as possible on both sides. I'm just going to tighten it down a little bit more. So what we do notice is that the actual servo shaft is at the center of the axis of rotation for the upper platens. So that's kind of key. Because obviously it's just going to be a direct drive situation. There's no belt or anything to be able to offset it. Something else, because it's an aluminum platen, I'm trying not to over tighten it, which could cause it to strip out the threads. And it may be something where if I do find that there's issues with loosening, I could add Loctite or some kind of thread locking fluid to be able to hold it in there, because there's no kind of retention to keep the screws from backing off with vibration or otherwise. But it may not be an issue. We don't know. So that's nice and secure. So going on to the next piece, we have 2 rings, and these will hold the bearing right above it. But before we do that, let's get this ready. So this is the bottom piece, and this will actually sit underneath the bearing, but it'll sit right here. But we have to mount this piece to it. So let's screw that in. It doesn't look like it needs any washers. Again, just snug enough, but not too snug. And I'm not sure if there's 2 different sizes of screws, but I'm using the shortest ones that make sense for each individual step. So these are just slightly proud of the surface as I'm screwing them in. But the difference is only about 1 millimeter or so. I'm pretty sure these are all metric, so. Okay, so we see we have our hub mounted to our plate. And now what we can do is actually rotate it until we see it start to lock into the splines. And there it is. Now we may want a particular alignment here because technically we don't know what position our servo is in. So I'm going to arbitrarily say it should be pointed back and hope that's right. So the idea with this little gap here is that we actually run the wire from the servo above through this hole in order to be able to get it down to our controller, and this helps it spin. Another option actually would be to turn it 180 degrees. And considering that the body here might actually clip the actual cable itself and cause it to bind up, I think that might be actually the best way to go. So let's do that. And again, I'm going to use a smaller washer. And unfortunately for me, I don't see if there's an actual washer there or anything else like that, but I do see 2 additional washers, so it's not clear what those are for yet. So we're just going to put in the screw. It is a solid hub, so there's no reason why it should have an issue. Unless this bottoms out, and then that would make sense. But it feels really solid. So already the backlash is pretty much minimal, and I think that's going to be just fine. So let's continue on. So next we have our bearing that we'll put on. Actually, no, we have to put 1 spacer plate, which should be level with this. So we'll have to use our standoffs in order to create that space. And actually we could build some legs as well. So it actually looks like they go in size order. So we have big ones on the bottom that go like this. Then we have medium ones. Look like they go like this. And then we have small ones at the top. So let's do that part first. We'll just do these 2, and then we'll screw in the top ones. And because this is just like a kit, it's possible they may have included extra parts, but it does look like there's quite a few extra parts. Which, granted, from my perspective, I'm not complaining about, but without instructions, it definitely doesn't make it easy. Alright, so we see this here. So we're gonna put this on top. And we're gonna screw it in with 4 standoffs. But it looks like these are supposed to be our spacers for the top here, which have to be screwed in first. So before we do that, I realize we screwed this in too soon, so we'll unscrew this from the hub, or from the servo, and then we'll be able to attach these standoffs to the bottom. And these definitely need short screws. And just so everybody knows, tomorrow I'm actually going to be doing the programming on this. So today is the physical assembly in order to make the platform that we're actually going to program. So be sure to tune into that as well. It's going to be around the same time, which is 1 a.m. Eastern. If you're watching this after that happens, you know, the VOD should already be out. I'm going to link to it in the description. So if the link's there, you could just watch it. All right. Right, so all of our holes are now occupied. We can put this back on. I just want to make sure we have 4 short ones for the top. Okay. So we can put on one of these rings. We're going to use the short standoffs. Looks like it does work. So now we're ready for the bearing. So hands are potentially going to get greasy. I'm going to try and minimize that. But you see how that fits in there. But this will give the lateral stability to be able to make sure that it's not going to be flopping around, and that's going to create that firm base for the camera shot. So we have 2 that need to clamp around. And of course the center one, which we're going to line up the 2 holes, the 2 sets of holes. Just to try and make everything going. So we'll do the inner one first. And I'm just going to leave these a little bit lightly tight, so that way in case I need to shift things around. But it did look like it was a pretty close registration in terms of what was actually how the bearing was sitting. So hopefully it just makes it automatically align. But I do want to verify that first. So looking at this, it looks like we're just going to be using some of these other screws here. And again, I'm not sure why there's 2 lengths, but there are 4 remaining short screws. So since I use the short screws elsewhere, we'll use these here. I know it's going out of focus, but actually, let's use the long screws here, because I think the short screws may be used for attaching the servo carrier. Again, we're gonna find out together. That's how that goes. Does it tighten all the way? Yeah, it does tighten all the way, so. So we see how that fits in there, and now the platen can't move side to side, like it doesn't flex, because it's surrounded on the entire edge. So I'm just going to tighten down these screws all the way. So it looks like it is in fact already aligned. We will find out. If we hear that it has difficulty moving, what we could actually do is just kind of loosen this up a little bit and let it work into its appropriate resting, place. So pretty much if you rotate it a few times while it's loose, it will find its own center, the path of least resistance. And at the end of the day, that's what we want. So right now I'm tightening it down, but we may have to find out whether that actually is the correct place. I don't have a servo tester, and actually I didn't think about it, but I probably should have configured a Pi Pico to be able to do just a simple rotation, so that way we could do this as part of that. But you know what? We live and learn. So next we're going to build up the upper portion of this. And that should be this screw pack right here and these components. So just going right off the bat here, I believe it's going to be like this, because I believe that this will center that particular, the shaft and everything else like that. I'm just using the short screws here to screw it in. Maybe it doesn't matter. I don't know. But I'll actually look on the side when... There's no way for me to tell, so I assume it doesn't matter. But I don't hear any creaking or bending of metal, and I don't feel unusual resistance as I get to a certain point. So I consider that a success. Okay, so we have that attached. Next, we're going to have our servo that will mount here. But first, let's feed through our cable. So we see how it goes through the bearing and then comes down and goes down underneath. And that actually puts both of our cables coming out the same side, which I really like. So what we're going to be doing is actually mounting this to another box, and that box will hold the electronics. And it's a waterproof box, and then my plan is on the actual tilt mechanism here, what I want to put is this quick release. So I have this on all of my cameras, and pretty much it just comes out, right? So this is going to go on the top on this, and this is going to go on the bottom of the box so I can mount it into a tripod or whatever other support device that I have that's compatible with this. Maybe it's a magic arm or a wall mount or whatever else. So I use these pretty regularly because I do like their capacity. They hold 15 kilograms, and it's also interoperable with the Arca Swiss mounting solutions. So actually we do need to mount this. And what this is just quarter 20. And I'm looking, I think we can make that work. Let me see. I got some of these nuts, well, screws, that pretty much are quarter 20. But my question is it going to stick up too far? So these do have like some auxiliary things here that potentially I could thread into with the appropriate size to be able to ensure it doesn't spin. And actually it looks like it's the perfect size. Oh, I'm curious if I have that size screw. What is that? I think it may be 2mm. Let's see. It looks like it is. Let me see what I got. So I have these right here. They're cap head screws, but they may actually work. Would it fit? No! It's the wrong thread pitch. It's the right diameter, but the wrong thread pitch. So it goes in a little bit, but then it just stops. Oh well. So that's something for another day. I'll have to figure that out. But it's not going to stop us from doing the project. It just may be something I want to secure a little bit more to get more consistent results before taking it on a hike or something like that. It is the middle of winter right now, so I'm not really going anywhere anytime soon, but I'll probably take it out to do some tests. And then the other side of this is also, will this poke through and make it inoperative to where I need a shorter screw or I need some washers? So let's screw this down and just see where we get to. Oh, and that might be perfect. Oh, that would be amazing. Okay. So I just tighten that as much as I can, and then I'm going to take a bigger screwdriver and tighten it a little bit more. And then we'll test pulling the plate on and off. Looks centered. I don't know if you could see that. It might be a little bit proud. Hopefully it won't matter. Let's see. Ooh. That is a little bit tight. So what can we do about this? This is a stainless steel screw. But what I'm thinking, maybe we just try shaving it a little bit. Assuming I have a file here. Let me see. All right, before we actually use it, I'm going to come up with something to put there. But I think for the time being, this will work fine, and I can work on just making something more elegant as we go. And centering this is not absolutely critical. But I think if I just file that a little bit, like I didn't actually tighten it down crazy here. And it does actually connect. And I can get it on and off. It's just kind of difficult, so remains to be seen, but let's keep going. So we need to attach this the actual servo. So let's open up this other package of screws. All right, we see some plastic spacers. All right, which actually might be for the servo. They definitely gave us extra parts here, because this math does not add up here. Let's see. So these two large washers look like they're for the bearing. We have some longer ones with thread lock on them. So this may actually be for the bearing as well. That's my guess, because it's got the thread lock already pre-applied. Let's pull out a few long ones, because, oh, these have... Some of them have the blue thread lock on it. So, not sure what makes those special. Just doing a quick sort, because there are some short ones here. And actually, I'm not sure if this is... So I'm going to do the short ones to actually mount the motor. And then I'm going to do... Well, then we'll figure it out. Again, just going a little bit snug until I get them all in. Kind of confirm the alignment. Oh, wait, these need the spacers, so these do have to be long. Let me verify that. Oh. Let me show you this. So if we look, it actually has the spacers down here. So what we were just doing was fine, and we can still get at it, so I can put the spacers underneath for the other thing. So let's do that. So it's adding additional clearance. Oh yeah, that makes sense. And just because of the length of this actually may bottom out as well, so I may want to put spacers under there to make it so it doesn't hit as we're going the full 180 degrees. I don't know if I said that, but the 25 kilogram is 180 degrees. This one is actually 270 on the pan. And so we'll have a larger pan range than we will tilt. So, which is actually great. So. Okay, I'm just going to press this down. Try and keep it as level as possible, so hopefully it actually ends up in line with the axis on the other side, which is there. Let's see, those do look kind of in line-ish. A little high, but I mean, I was pressing down on this, so not sure how much further it could go. So, let's put the spacers under here. All right, now they look lined up. I want to put this back, and they're not going to be lined up anymore. Let's see. Going to try and drop in the screws because it'll be easier to line it up if they're not all over the place. Oh. That worked wonders. Right, so these actually look like they're in. And I'm going in a cross pattern, just across. That way it just kind of centers. It doesn't fork it in one way or the other or twist the metal. So we see how that plays right there. So there we go. So now we can put the cross piece. All right, and I believe this will just go on first, but let's see how it lines up. So yeah, it does look like, right? So the pieces are there, so we could put it straight up in the air, which I think will help us with the attaching it. But we see how that just kind of fits on there. It feels very solid. And I'm going to use another short screw to attach it here. All right, and then on the other side, they never even show it to us, right? Because I'm looking through it here. Oh, we kind of have it here. So we kind of see how that goes. So the bearing is there. It looks like it's captive through the washer. So one of the large washers. It's going to be one of the long screws. I'm going to put, again, the one with the thread lock. And it will go like that. And this one is actually an interesting... It's a flanged bearing. So it's possible it actually goes in from the inside. So these two sides are the same, so let me just put it in this side. Yeah, because then it looks like it is recessed on this side a little bit. And then we have two microscopic size washers here, which I'm sure go on the inside of this. Alright, so maybe it does need to go on the outside. So we actually could probably put this all in one assembly. So let's do that. Although I don't like that because it looks like it'll rub, and if it rubs, it's going to make noise or be or start introducing issues. So I'm going to put it in like this. So where did we put the blue thing? Right there. Because then it'll go like this. So I think that makes the most sense. Assuming we don't lose the only bearing that we have of that type. Okay. And then we have 2 washers. And it looks like it may just work. I'm going to try and put the polished side in for the best one towards the bearing, just so that way if it does rub, it's got the best chance of just ignoring it. And that actually looks like an exact thickness. But it doesn't actually really reach the thread lock after all of that. Alright, so and this is not particularly easy. So I'm trying to keep everything together on the same shaft. I'm also trying not to scratch the anodization. Did I succeed? I don't know. Alright, and I'm going to tighten this down fully. Hopefully, again, without stripping it. Alright, and it does feel like it's doing a thing. Alright, and I do see the bearing rotating. I'm not sure that there were longer versions of that screw, because these do not seem... This particular one does not seem long enough. Is this one longer? It's the same exact size, but I'm going to try it anyway. I don't know. We'll figure that out. Alright, so now we want to do this side. The hub is threaded, so we're going to use the short screws. Try and get it in focus. Alright, so I'll just put that in for alignment, try and put in the second one. And the fourth. Alright, so that's that. I'm just gonna check range. Looks like it does have a hard stop there. Alright, but the screw does not interfere. But that's fine. I may actually put a standoff just so that way we can reach the end of travel. Looks like a 1/2 inch or so, but that shouldn't actually be an issue. And we'll just check the pan. And hopefully we didn't just wreck it by exceeding the limit switches. So, we find that out. So, now that we have this built, we actually want to mount this to something else. So, there's a lot of extra parts that came with it. So I'm just gonna put these away really quick. I don't know that I checked these, did I? Oh, I did. How fun would that be? Alright. So we will put those there. Let me get these other things out of the way. Okay. So now what I have to actually put this in is a box that I've used previously, so it's just kind of recycling. But it's nice case, I just gutted the electronics out of it. And what it is it's just a simple enclosure. It's got a an acrylic or polycarbonate, sorry, it's got a marking, but a polycarbonate lid that latches closed, which makes it watertight. And then, you know, it has some mounts, but I'm actually going to remove those. But I've pre-drilled some cable glands through these for the previous application. And there's also some holes going through it and things like that, which I have to put silicone on. But I'm going to try and reuse these holes in order to be able to connect to things like the servos, as well as battery input, things like that. And what I'm actually going to be using for this is just an RC car battery. So the servos themselves run natively at 7.4 volts, which is perfect for, you know, just getting off-the-shelf battery components and things. And then I'm going to use a step-down converter, just a little small one, in order to provide the 5 volts for the Raspberry Pi Pico. So, but pretty much we're going to be putting everything in here, and as part of that, I actually want this to somehow mount on here. And it is very close. So the question of how we do that is another story. Because obviously I don't want to interfere with the ability to be able to open the lid. Because I could go like this, but then you couldn't see the window or open it in operation. So let's see what we can do. And it may be something where I'll have to make something off camera and try it. But the idea being, we have the connections for everything go through here. So I did really just want it on top. But it actually looks like the servo mount is in the way of these existing cable gland connections. So I'd have to offset it significantly. So I'll have to figure that out off camera. But I don't think that's going to impact anything going on today. Because one of the nice things is it does look like I could potentially just fit these connections through and just put some headers to be able to accept these particular servo connections. So I'm just going to take advantage of that and be able to just utilize these. Or I could always just fill them in. So what I actually usually do is take a piece of rolled up rubber or rolled up mastic tape and put it in here and then clamp it down. And that does make them watertight again. So, you know, I'm not trying to go too crazy with this. The extra hole is not going to make a huge difference. I do have another case that I could use that is larger, which, I mean, let's compare. Let's contrast and compare. I got it right here. Now, the reason I was actually trying to avoid this particular case is it doesn't have the convenient lid. And I really didn't want to buy another case. I stock these cases for, you know, whatever reason. So I try and use what I have. But this one has a few nice features in that it has the PCB holder on the back. Let's see how it fits. And survey says, I don't know that it's any better. So realistically, it's just a little bit shallow. I don't want to go through the polycarbonate just because then I won't be able to take it off. I don't want it to be unstable because depending on the weight of the camera and the angles that I'm using it on, you know, that's going to potentially create issues. So let's see what we got. I'm just gonna keep running with the with what we currently have, which does require solving a few issues, but I mean that's half the fun. All right. So next thing we're gonna do, I'm actually gonna, well, I want to cut a mount. Just because I need to do it at some point. And what I have, because we don't have a PCB thing, is I have this piece of plastic that's an offcut, just from something else that I made. And this doesn't have to be exact. Doesn't even have to be square. But I am just gonna put a mark here. There's, if you can see it, the nuts inside actually protrude slightly, so I want to make sure to avoid those. So I'm just going to leave a little extra room. All right, and I'll just make that a square. So let's move this off to the side. I'm going to move the soldering mat out of the way and actually pull out a cutting mat. Okay. So let's see how long it is. Oh, look at that. So what is this per division? So it's a 1/2 inch per division. So 1, 2, 3, 4, 5 inches exactly. Alright. So I have a 6-inch ruler. We need to go down 5 inches. At least. So I'm just going to put a mark there and then measure over 5 inches. And I'm just going to use the mat for the other side of it just to be able to see it. And the reason I'm just aligning it is to make sure that it's square. Right, so we're going to go to there. So let's go ahead and cut it. I'm not doing this in one pass because I like my fingers. Alright, it is cutting through. And there it is. Now, it may not have gotten all the way to the corner, but I can clean that up as soon as I make the second cut. Said I was going to use the other thing, but I never marked it. Okay. All right. I don't have a side angle so you can see what's going on with this, but I think that's fine. Right, so we see it's there. And we just clean that up. So that's going to be our platen that we're going to mount everything to. Now, I don't actually know if this is going to lay out properly. We're going to have to find that out. But my plan is to put a little DIN rail mount here because I actually want to put a small, tiny little fuse for the battery, as well as some terminal blocks as needed to be able to handle the power input, things like that. I think it's just going to be safer and nicer. So just mounting this will be the way to go. And then next to that, I need to find where I put my PC board. Which I definitely put somewhere. Otherwise, I gotta get another one out of the bin. We're gonna find one. Let's see. Well, we have two options. Since I'm pulling it out anyway, I got a larger one and I got a smaller one. They both have the exact same surface area in effect. Right, so we could put this here. And this will have our actual microcontroller and all of our connections to be able to get to our servos. Another option would be we could do this all sideways. I mean, realistically, we could rotate it after the fact. So we can get that figured out. Because I have these smaller ones too that don't have as nice of mounting holes. I like the fact that this has 4 mounting holes, so I can put in the receiver sockets to be able to accept the Raspberry Pi Pico and be able to plug and unplug it at will. So we're going to keep that handy because we're going to do the soldering here as well. So I shake the camera and everything. Let's see. All right, so the critical thing with this is we see the 4 holes here. Whether I have actual screws to be able to mount into that is another story, but I will by tomorrow. Oh, I have all of these. I have to dig them out. No, it's going to be too much. So I'm going to worry about that later. But we drop this in. We see, wow, it fits beautifully. So that's going to work out just fine. I may need to do some additional modification in terms of making sure it's able to accept the diameter of cable that we're looking at. But this is going to be mounted before we actually put through any of the wires. So as long as it sits on here, it's not going to be floppy and it's going to be very secure. I think it's going to be more than adequate for our needs. And then what I'll do is I'll just punch in some small holes. You know, a good way to do that is actually put in the screws into, or put in the bolts into the holes, and then use the plastic and just press down, because this is just a quarter inch or like 4mm PVC expanded sheeting. So I use this a lot for projects because it's structural, you know, or semi-structural, non-conductive, and you know, it's pretty cheap and easy to cut. So I do like that a lot, and I'll probably go through, maybe chamfer the edges a little bit. But the point being is that you can just put in the bolts in the hole pattern that you're trying to copy, and then press down on this. It will leave an indentation, and you just drill the hole wherever you have the indent. So that's the idea behind it. But again, not critical to do here, but I will do that obviously when I mount it. So next thing is we just want to create a controller. So I'll show you what I got for the controller, right? So this is going to be the box that has our pan tilt zoom head on it. And I wanted to make a controller out of this box. Okay, and I got it specifically for this, but I like these boxes because they're UV stabilized, they're easy to drill. Again, it's PVC, and it's something that is easy, very easy and convenient to work with. So, and they're also waterproof, so that's a plus. But pretty much within that is going to be this joystick. I'll pull it out. All right, and this joystick just works. It has 2 potentiometers on the side, 1 for each axis. So when it goes this way, it's adjusting this potentiometer. When it goes this direction, it's adjusting this potentiometer. And you can see the yoke on the bottom and how that works. So when you do, you know, directions in the middle, it's moving both of them simultaneously. So the nice thing about this is because this is just 2 axes, it's just going to do a single output on the center, which is the sweep, and it's going to give us a voltage between, we're going to connect 3.3 volts over here, we're going to connect to ground over here, and it will give us the range in between based on where it is in its, what position it's currently in. So when it's at the normal position right here, it's going to be at exactly half that voltage. So based on that, we can determine how fast we're trying to move the servo and on which axis based on each one individually. So we don't have to read it, we don't have to do any crazy math or anything else like that. We just say, here is our range, you know, what is our percentage of saturation of the particular analog input on the Raspberry Pi Pico, and then, you know, we'll move accordingly based on how fast we want to move. So that's kind of the overall idea. But But I want to mount this inside of the box because obviously I want to have some way to hold it. So I'm going to put it around there, you know. So that will sit there. It has this nice little ring that holds down a rubber gasket that makes it water resistant. And that actually holds the whole assembly together. So then when you move it, you see the gasket moves with it. And then I actually want to have some buttons. So I got these waterproof little buttons. And this way we can have maybe 3 buttons going down. You know, it's not a game controller, but it's pretty similar. Right, so we could have 3 buttons going down to have 3 actions. All right. Now, because we obviously have to connect somewhere else, this is not going to have any actual electronics in it by default, but we are going to have to connect to this box. So what I got are these tiny little connectors. And I like these because they're multiple pins, they're waterproof supposedly. But they're these nice little, looks like positive locking, but quick connects. You know, none of this stuff is sponsored, but it's just, find it online, I got it. And, you know, do I expect it to be, you know, I don't know that I would put this in a mission critical application, but it is something where for hobby use, like I'm going to use it, I think it's more than fine. And it does feel like it has a gasket in there. But I think this is going to be nice, so I'll make a cable that just has 2 of these connectors. I'll put one of these jacks on the side of this box with all of the connections from here going into it. I'll do the same thing over here on the side of the main box that has obviously power, everything else like that it needs. And I'll just be able to connect the 2 of them together. It's going to make it a lot easier to store so they're not permanently attached. And perhaps it'll also enable options in the future where I could do semi-autonomous movement with this without the controller, like doing a pre-programmed cycle. And, you know, it's just, at the end of the day, we're building this, so we can make it whatever we want. So, that's the idea. And let me actually just push some of this to the side. This is the joystick. I don't have a bag for that. Big thing is trying to make sure that we're not losing parts, because some of these parts are incredibly small. So we need to find out the diameter of this. I do know the diameter hole that it needs for this. And then I believe these are 1/2 inch. So we're going to check that. And then we can lay this all out on top of here and then be able to drill into it so we can make all of the things. I'm just going to clear a surface area real quick. All right, and the first thing, I am using pen for this, but I'm going to wipe it off. I'm just going to measure and draw a center line, which I'll be able to use to be able to line everything up. And it's probably going to be better to use centimeters. Right, so here we see it's 67 centimeters, which makes for really nice, easy division. So we're going to do 33 and a half. Is that 33 and a half? I think that looks good. I'm just going to double check it by measuring both ways. Looks good. And we'll make another one and then draw a line between them. And it is close enough. And we do go through the center line on the box, which is a good sign. Okay. And it's hard to see, but I can see it clearly, so that's fine. All right, and then this, we want to make sure that we're actually over far enough so we're not running into the side of the box. So, because no matter what we do, something's going to be near the edge. So we could actually, just to get more space, let's turn it around this way. And here we see we actually, because we're lining up on center line here, you know, we're always going to have the space here. And this side is not going to be as much of a concern because we'll have a space before the buttons anyway. And not to mention it's going to be below it. So now that we got an idea of that, I'm actually going to use the screw holes on this and just align it with that line. And I'm going to put a mark right here. And I don't think my pen will reach through it, but see how close we got here. All right. Now, to this point, we haven't opened it up, but before we drill anything, and actually I'll just finish this up just so you see it. So I just put a little mark here just to show the exact center point for where I'm drilling. I'm going to open this up and just let you see the inside construction. Because it is literally just an empty box, but it is something where there's a gasket groove that we need to make sure to avoid and make sure that anything that we drill or otherwise is not going to perturb, otherwise it won't be waterproof anymore. Now, I do have a second one of these boxes should it be needed, but you see how pronounced that particular groove is. And what that groove is actually for is this gasket. I'm not going to put the gasket in now because I don't want it to get covered in chips or get damaged, but we need to make sure that it is going to, in fact, kind of avoid that whole thing. Right? Because we see here, it does fit when it's centered, but there's all kinds of other things here in play that we want to make sure are avoided as well. So we may want to give it a little extra room, but we do see side to side is no problem, and actually the base is even bigger. So the connections, everything else like that, are not going to be a problem. So let's just move it over just a little bit, which is why I didn't make that full mark. Right, so we'll move it right here. And we'll just make a little mark. Okay. So that'll be the mark. You can't see it. Oh, you really can't see it there. But point being, there's a mark there. Unless I was using a white paint pen, you're never going to see it. It's a black case. But the idea here is that we're going to try and drill this out. I'm going to put the gasket off to the side just so it doesn't get dirty or destroyed. I will also move some of the other stuff out of the way. I am going to put in some screws, although they don't really need to be tightened all the way. And since the biggest component is going to be our biggest restriction in terms of what we can do movement-wise, we're just going to go ahead and drill that. And then we can actually kind of get that staged and then figure out where we're going to put everything else. Because it may be we need to put buttons on the side or put buttons staggered in order to get higher density, which will be just fine. Or figure out something else, you know, figure out what we're going to do. But I do know, no matter whether we use it this way or the other way, it's going to be located right there. So let's drill the hole. So I have a 1 5/8 Forstner bit. All right, and ordinarily, if it wasn't winter, I would have pre-drilled this on the drill press. Because it is winter, I'm going to use a hand drill and hope for the best. So let's get this chucked up. All right, I am going to try it on a high speed. I'm just using regular battery powered drill, but I am going to wear safety glasses because I value my vision. Although, ironically, when I have them on, I can't actually see. So, a little too much glare in this particular condition, but I think it'll be just fine. So, I'm going to do this so you can kind of see it, but not really to hide my mistakes. No, I'm kidding. And I just want to make sure I'm aligning appropriately. And just for metric folks out there, so the 1 5/8 is actually 41 millimeters, which is the suggested size. So we're going to try this. I'm going to stand up, be completely out of frame. Okay, so that actually did a pretty clean hole. So the thing with this is it makes a giant mess. So it's great, but you see the, from the amount of plastic everywhere, why you need safety glasses, because it's just throwing stuff everywhere. I'm going to take a second here. We're going to clean this one up. The other drill bits, thankfully, don't make as much of a mess, because this one technically kind of burned through a little bit, which is just fine with me because it didn't leave a burr. And we see the little piece inside. It didn't actually cut all the way. So let's actually dump everything out. We're gonna make a mess. Let's finish making the mess. Right, and the reason I had the box attached is so it wouldn't do weird things when the drill slipped through. Because it does have a groove, so it would have stayed aligned while I was pressing down on it. But as soon as it went through, it would have pulled up. And that's pretty typical for drill bits. Alright, so I'm happy with that. And it's actually not going to be seen ever, because here's the wafer, by the way. Because it cuts the edge before it cuts the center. So the wafer is left behind when it punched through. Alright. And I'm just going to try and get all the little fuzziness out of here. Good enough. All right, and same with this. Because the idea is we want to leave this top surface as pristine as possible so it doesn't look like there's a bunch of machining marks, things like that. By the way, if you're ever blowing into a box or something to try and clear dust out of it or something, always close your eyes when you're doing it. Even if you're wearing glasses, it just keeps a lot of things from getting in there. May sound obvious, but some people learn it the hard way. All right. I need to clean this up because this is triggering OCD right now. Also, it's going to be really annoying on my arms. So, we got that. Now what we want to do is actually put in the control. So this will actually fit in like this. We're going to poke through the gasket like that, and pretty much underneath it has these little tiny holes, and those correlate with the spacing on the gasket, so those will sit behind, right? So the gasket goes in front, those will sit behind. And we'll need to just drill those holes so tiny little screws can go through. And then the idea is that this goes on top, like so, compresses everything together, and makes it watertight. So it'll look like this. So I think that's going to be good. So let's figure out where we're actually drilling. Best way to do that is to actually line it up using this and try and center it. So this is the outer ring. This is perfectly aligned with the bottom here, the screw holes with that. So we should be able to do it. I can't mark through there, so what I'm going to do is actually take one of the screws. Right, and I did include an extra one, not for this purpose, but in case you lose it or in case it breaks, because these are especially tiny. We did get just a little bit of drift, but I think that's going to be just fine. And something else is we could put a little silicone around here if need be, to be able to make it so we're not in a situation where any like little gaps or something like that, if there's a misalignment, are going to cause a leak. So that's part of the nice reason of having the diaphragm, because there is another type of pan tilt controller, and I'll show it to you because I did buy it. They're not expensive, but these are the same ones that are in like old style PlayStation controllers, game controllers, things like that. They work on the same principle where they have the actual X and the Y, and in this case it has a button as well built into it. But this wasn't what I was looking for. I wanted something that was water resistant. These are not water resistant. They may be able to take a certain amount of abuse, but you know, it's not for this particular project. So I did get some because I do want to use them for future projects, but that's kind of the background on that. So if you don't need water resistance, you know, it's probably a good match for you. So what I want to do is just kind of get an alignment here. and just see where we sit. I don't have a square to be able to judge this off of, but I do have the edge. Well, actually, I do have a square. So I'm just going to place it aligned with the mat. And I'm going to line it up with the perpendicular lines. I think that looks pretty good. Let me see. Sorry, I'm putting my head all in the way, but... So I'm just going to hold it down. I don't know if I made a mark. Kind of. I think it was too smooth. So let's try this. Will this fit? Nope. I don't have a an awl. An awl would actually be the appropriate thing to use for this. But what I do have is a very tiny Phillips, and let's see if that reaches. That worked. Okay. So. What I have here is just a drill bit set. Let me pull out the right drill bit. Oh, I found the PC board. And let's see. So I'm just going to line it up visually here. Right, and these are standard drill bits, so I believe 3/32 actually looks like a good size. So let's go ahead and drill that out. Right. Okay. This goes without saying, don't put your finger behind the drill bit when you're drilling. So, I didn't do that. I was off to the side, but it should be obvious. So now we have our 4-hole pattern. So now we should be able to mount... We should be able to mount our joystick. So let's try it. And this is just to test it and also to get our layout for the buttons itself, because we want to see it kind of in place. So I'm pulling through the gasket. I actually don't know what size this needs. Let's see. These are very, very small screws. Because these are so small, I can't necessarily see through them to actually get the alignment. Let's see. Here, I might just need to get this started really quick. Right, I'm just gonna tighten it. I don't want to over tighten it, but I do want to make sure that it's making a good seal. Right, and that looks good. So now when we actually put this inside the box closes. Use the thumb, Joystick around. Looks good. So now we just need our buttons. So these are our action buttons, and we need to see where we can fit those. And realistically, we can put one here, here, and here, slightly offset from each other. Now I just want to count really quick, double check I'm not putting too many buttons. So that may seem obvious, but I only have 7 pins on that connector that I'm going to be putting between this and the actual pan tilt box. So we have 6 pins here, okay? We actually only need 4 in order to drive this, okay? And the reason being is that we have 3.3 volts, we have 0 volts, we have the ground, and then we have the sweep. Here, we have 3.3 volts, we have the ground, and we have the sweep. So 3.3 volts can be shared between the two. The ground can be shared between the two. And then we just have the sweep, which obviously would have to go back as an input to the Pi Pico. So that's 4 pins in total. So we have 3 more pins that are available. But if we look at the buttons, wherever I put them, I have the other buttons. So if we look at the buttons, it's got 2 wires. But the way that we're actually going to wire this up is we're going to do a active low. So we're going to attach this side to ground, and we're going to attach this side to the pin, and then use an internal pull-up resistor to be able to actually wait for the button to momentarily short it to ground, and that will be our actual input. So we can share the same ground connection that we do with our potentiometers, and we would just need a single individual pin for each button. So 3 buttons is fine. So we have 4 plus 3 to make 7. So perfect. We can fit the 3 buttons, and we'll define what those actions are at a later point. Or if they even do anything, but we know we want to make the controller have the 3 buttons. So let's come up with our offset. We want to line them up, and we want to make them the same distance off of that center line. So that way everything has a certain symmetry about it. Right, so I'm lining up with the edge here to just try and eyeball a constant offset. I'm going to come up here. I'm gonna use inches just because that is what I am comfortable with. And I'm just gonna put a small X at the 3/4 inch mark. Right, which is about, I think, 2 centimeters. Right, so those are in line with each other. And then we'll create the third one as an offset right on the center line. So based on how thick this is, obviously we want to be able to screw it on. So we'll take our button again. Right, so we have this one here, which that should actually should be just fine. So we're going to do the same thing with this. And what I'm doing is I'm just sighting it so that way I can see where the edge of this is. At the same time, I'm looking at the edge of this, like the corner specifically of the nut that actually holds it together, because we have to be able to spin that nut or spin the button. So let's see. Around there looks fine. So let's just try this. And I think that'll be nice. So it'll be just kind of following this same curve with the buttons. So let's go ahead and drill those out. But we need to find out exactly how big a hole we need to make. Again, I believe it's 1/2 inch, but let's verify that. So let me actually get a caliper. Put my caliper. Oh. I put something on top of it. All right. So this is just run-of-the-mill caliper. I use analog dial because the batteries always die on me and then it becomes garbage. So I just decided to forgo that. So what I'm going to do... Right, so we'll just take a measurement. I'm going to put it on the thick part so that way we kind of ignore the threading. Spin this around because it does have some flat sides. Right, and then we'll take a reading. So in this case, in inches, it is just shy of 1/2 inch. If we actually go to here, this is 1/2 inch. Millimeter wise, it looks like it's actually like 12 millimeters. So is the actual appropriate size for it. But 1/2 inch for me is just fine. And in my case, I'm going to use a stepper bit. And the reason I'm going to use that is it does a progressively larger hole. And it's easier to drill in plastic. It doesn't burn it. It's less likely to burn it. Or I should say, and it's less likely to wander off. And that's a big thing, especially when you're trying to do precise holes. So just really quickly, I'm going to use this as a punch. And just divot the plastic so that way it has somewhere to kind of start. And I'm going to use a very small drill bit just to put a pilot hole. Right, and the reason I'm going to do that is so it has a hole to follow as it's actually going down with the larger bit. So I'll use the same drill bit that we had before. Put on safety glasses. Right, and I think that placement looks pretty nice. So I'm not going to complain about that. I could complain about it, but I'm not going to complain about it. And let me grab the stepper. I can't see it, it's too dark. Let me see. Okay. So, as I roll off into infinity, I found the stepper bit. So, this is a stepper bit right here. Again, it's standard, but it's really good for drilling things like metal, plastic, wood. Generally, you know, it's only good for the thicknesses that are actually available in the steps. So for wood, it's not really going to work for you, but for thin stock like plastics and metals, it's going to work great. And we even have the option to do 15-30 seconds here, which may be a more appropriate size for this button. So I am going to try and stop there. I do have a mark on there, probably from when I drilled a similar sized button. Let's see. All right, in this particular case, it's going to bottom out and start going through the bottom, so I do have to hand hold this. Okay. We're going to try one hole first. Notice how much cleaner that was, and it didn't melt, and it leaves a very, very clean hole. So let's try it. Where'd our button go? I'm putting things down. Oh, I put it in the bag. Terrible. So let's see. Oh, that doesn't look too bad. Oh no, it's got a lip we didn't account for, so that is the extra ½ inch. Okay, so this is probably a 13mm button. Something else I want to point out, these don't appear to have a rubber gasket with them. So I would have to glue them down or something else to make them actually waterproof. But I think for this purpose, it's going to do just fine for now. I can always glue it later. So let's go that extra step. Okay. Looks good. If you damage the other thing, that's probably a bad sign, so good thing we didn't do that. Oh, even with a ½ inch, it doesn't sit flush. What size is this? 1 minute. 1 minute. So it is slightly... It is actually 13.2 millimeters. So interesting. So maybe a 14mm button. But in this particular case, do I want to try and go a size bigger? And the nice thing also about stepper bits is that they will actually, they're easy to step up because you can just use a slightly larger one. So like I could go to 9/16, which may be too much. What other sizes do I have? This one, also 9/16. See, right now you could tell... Yeah, the camera's going crazy. Let's see. I have this, but I don't know that this is going to be thick enough, but this will give me 16ths. So I could... No, that's 9/16. So I think the option is to go to 9/16. Yeah. Yeah, so the highest precision that I have is 16ths past the half. So I'm still going to use the half in order to get to this far. So let me actually just go ahead and drill all of them. Okay. Again, don't put your hand behind the drill bit. Should go without saying, but... Perfect. We will move all of that over to the side. Let's change to the other bit. I'm just going to take a quick gander. Right, they do not look like they will interfere with themselves or the sides. So I think that's perfect. And actually, we may have to stop there because of the nut they provided. Let's see. So here's what I'm going to do. Okay. So because the step is very shallow, I'm only going to just drill a little bit using the 9/16 so it has enough to be able to take that registration. That was tiny little step. I'll zoom in so you can actually see this. But see that tiny little step? That is the slightly larger diameter. So I'm just going to drill just enough to be able to accept that, but not go all the way through so that way we have more meat to be able to attach to the back. So let me do this. Right. And we're just going to go a little bit of this step. I'm going to try and position it so I both don't cut off my hand. And we want to go one step past the half. So that looks like my other ½ inch is maybe a little bit undersized based on compared to this bit, but that's not unusual. So we'll just start it. We see it's not really taking off anything. Okay. And we're just going to go in a little bit further, but not all the way through. Okay. So that is 9/16 halfway through, but it's a ½ inch on the other side. Let's try sticking in the button. All right, and now it is sitting flush. Right, because before, we have other holes I can show you. See how it was sitting proud? So there was a gap. So we got rid of that gap by doing that. So let's do that to the other holes. I'm actually going to turn it on the low gear just so I have a bit more control. Okay. And you can see that step. It's not the prettiest thing ever, but nobody will ever see it. So don't tell anybody. So let's see. All right, so that is that part. So now if we check, button fits down flush, button sits down flush, right? And the button sits down flush. So that's very nice. So before we put it all in, I'm just going to wipe the surface a little bit. And no, I'm not going to get isopropyl alcohol now. I'll get it later. But we can attach the buttons. And I don't know that I'm going to use the lock nut, just because it looks like it's causing threading issues. and I don't think it'll be an issue. The body of this is plastic, so it's not particularly, you know, not wonderful to try and get the nut on or anything else like that. Okay. It's got a tiny bit of play, but that's actually okay, because I can do a little bit of alignment to push them around. All right, and the other two buttons. All right. Not sure when I switched over to that. All right, now everything gets really tight here, so it's really hard to get this on. I do have pliers if I need it. I know I need it, but I do want to get it started without the pliers. Otherwise, there's potential to cross-thread it. I need to find, I have better safety glasses that aren't scratched, so. Because usually when I'm working on projects, I wear the safety glasses the whole time. And that's not even like a, you know, just virtue signaling kind of thing. Like, that's a real thing. But when I can't see through them, it's impossible. So. Right, so that's 2. Last one. Then the only thing we got to do is we got to put the connector in on this box. So it's just one hole in this box, and then we just solder it all together, and this box is done. The more connections that go on here, the harder it is to get to. And I know it's going to be fun to solder the connections onto the potentiometer as well, but I think we'll be able to make this manage this. The rest of the box is actually just empty. You know, it could be something where in the future, if there was a small battery or something like that that could power a small Pi Pico and power the potentiometers and things like that, it could potentially just be a wireless controller. You know, that could be really cool. But that is, I felt that was a little bit much for today. I'm just going to get this started. I'll zoom out. See the full mess. Right, I feel it cross-threading, so it's going in at an angle, so I'm trying to correct that first. And once I get it to bite, then it will self-feed. let's make sure this lines up. While we still have a little bit of play, and then tighten it all the way. Perfect. I like it. I think it has a nice flow to it. You know, this still works like this. I can hit the buttons, actually recall presets, things like that is the intention of it, and then be able to control the camera. So I'm happy. We just need to now get everything put into the box, but before we do that, let's get this tiny little connector put into the box as well. Now, notice how tiny this is. We do need to solder this outside and then push it in, and you see the rubber gasket here, which is also holding the cap. That will seal it against it, but we're just going to cut the hole first, so that way we have this as a template. So we're going to do the bigger diameter, which will give us our general registration, and then we'll come up with our alignment and drill the smaller hole. And what this has to actually mount it are just some tiny bolts that are the appropriate size for this. And I think that this is, again, 3/32. Or less. Let's see. Oh, I think it's even less. Let's see. 3/32 looks like a, it might actually be too big. But I have a massive case of drill bits. So I don't know if you do this, but I buy the bulk fun packs where they come with like two or 300 drill bits, especially of the smaller sizes, and I just aggregate them together in one case to have them around. So when they break, I just get rid of them, or if they dull out, I can put them in a big pile and sharpen them all at once. But it makes a big difference in terms of doing it, and since they're cheap drill bits, it's not really a big deal. So, let's get a size. Right, so in this case, it is a 1/2 inch once again, I think is a safe bet. So, let's use that original stepper, drill bit. Let's drill that out. Right, and before I actually drill it, let's just come up where it's actually going to be. And the nice thing about this is this will mount both ways on that cover. So if we don't like which side it's coming out on, we can always reverse it, and I don't think it's going to be encroaching enough to where it is an issue. Because this really isn't going to stick out much further than the actual side. So I do believe we're going to want it to be this height. Just so it's at the bottom. Because it looks like this is, you know, this is the base. There is a little thing here, but I don't think it's going to be much of an issue. And since there's no active, like if we were putting a PC board in here, we'd obviously want to keep that and use it. So we'll go just a little bit higher. And our bit should actually wear away at that enough to be able to work with it. And then we want to go in the center of the box. I don't think that's the center. that's where I would put a line if I didn't want it to be in the center. Okay. All right, I think that's good. So we'll do that one right there. All right. I'm not gonna do a pilot for this. And we're gonna see if I regret it. Okay. Nope, I don't regret it. That looks very centered. I was probably zoomed in way too much for that process, but that's okay. All right. So we'll take this, and the way it goes is like this. And it will just sit in the end right there. So I think that's really nice. And what I'm going to do is, because we have this, I'm going to take off the rubber gasket, just because we don't want to drill through that. I'm going to put this all the way down, so it's just this connector, which does happen to be plastic, but that's okay. And I'm just going to use it as a drill guide in order to use the small drill bit. Alright, so I have 5/64. Will this work? I think it will. Now the key thing is we want it to be as square as possible. So I'm going to hold it by the bottom and just press it down since I want it to go in that direction. We see how it doesn't interfere with that bottom thing, and it actually got drilled away. No, it didn't at all, so that's fine. So I think we put it in a good position. And I'm going to try and make it square. I'm just going to drill one of the holes. Right, and that looks good. So we see it there. And now what we're going to do is we're going to put in one of the fasteners in order to make sure that it's not going to shift out of alignment while we're drilling the next hole, and then continue it from there, etc. You know, to be able to make sure that we do it in a clean way. I'm trying to find where I put that bag of screws. Or did I leave it over here? Oh. I moved it off to the side and forgot. So. Right, so this is the actual screw. I'll zoom in. So we drilled out this hole. Right, and that can just go right in there. And that will help us keep the alignment as we drill the second hole. We don't have to bolt it down. As we go through, every time that we drill a hole, we'll put the bolt in it. So let's drill the second one. All right. Okay. This, they did not waste any money on the bolts, so they only gave you the exact amount that you need. Perfect. So now we have all 4 of those mounting holes in place. We're not going to screw it in yet, and the main reason is because we're never going to be able to solder it. Because if you look, it's kind of set up coaxially to where there's a center pin and then there's stuff on the bottom and all around it. So we don't want to do that, but we can kind of get a feeling for how this is going to look. All right, so if we put this together, and to be honest, let's see, will it fit like this? Because if it does, yeah. So I like this better, and I'll tell you why, is because if you have your hand like this, you don't have a connector jabbing into it. Another option would have been to put it on this side, so it's just coming out this way. But I do like it kind of going out the side, and then there's also the option of holding it like this, which I think is another viable thing. The thing that's going to dictate the actual direction that you hold the controller is which direction you put the labels. So, just something to keep in mind. But I think I'm happy with the way everything looks. You know, it's kind of coming together very nicely. So, let's go ahead and get this prepped to solder. So before we do anything, let's put these screws in a very safe place. Now the key thing is, because this is going to insert into the hole, when we actually are putting it in, we're going to want all the wires to be coming through the hole first before we solder them. Otherwise we'll be on the wrong side of the hole. I wish this was just a Ziploc, but we make do. Okay. Okay. So the key thing is we also want to write down our pin, because we don't want to open this after we close it. Now we have our wires here. These are all going to get tied together. These are all going to be different pins. And then we need to attach connections to these as well. So likely what we're going to do is, to minimize the amount of cabling, we're going to cut these short and just put these to the same pin with another pin, you know, with another cable coming out. So it's 4 pins into one. You can't see that. So we're going to cut these as short as we can, do 4 pins into one. So that way our grounds are all tied together and we get rid of this much wire, which would be consuming space. For the other connections, I do have some hookup wire. Actually, before I did that, probably should have put the bit out. So, and this as well, technically we could stretch it over, but we want all the wires to be coming through here. So let's put that back on. Perfect. So let's come up with that. I believe this is set to go. It auto turned off. So we went so long, it auto turned off. And let's get some lengths of hookup wire that we can use. All right, in this case, I have a short end that I can use. We'll need some more colors. Let's grab one more color. So that'll be perfect. All right, and it doesn't need to be that long. Just needs to be enough. And I like to kind of twist all the wires together to make a nice little harness. And we'll cut it. Same thing up here. And it doesn't really matter because we're going to strip it anyway. All right, but this is going to run to our potentiometers. So we're going to make red as hot, which is going to be our 3.3 volts. We're going to do black is going to be our ground, which we're going to jump between them. So we're going to have to put jumpers on these two. So we can actually cut that now. Get my cable stripper. This is a pretty big project, and I don't have enough area on the desk to have all of it here. I did have another desk that I could probably have done this project on, but I didn't think about it, honestly, so that's how that goes. All right. That is the black wire. Now, based on which side we put the hot and which side we put the common, will determine the direction that it actually goes. In this particular case, I'm just going to hook it up so it is consistent, and then I'm going to compensate in software so that it moves in the direction that I want. But if you did want to have it, you know, move a particular way, generally it's the opposite of which way you want it to go would have your, you know. So if you move it this way, it gets closer to this wiper. If you push it this way, it gets closer to this one. So just something to keep in mind. Or I'm sorry. If you push it this way, it gets closer to this one. So think about it. It's twisting the wiper this way or this way. So that's why I'm compensating in software. It just doesn't matter. I don't want to have to deal with it right now. All right. And then based on which direction I'm holding it, green is the green and the white are going to be our two wipers on those particular potentiometers in this little set. All right, so we need this to jump over, so I'm going to twist these together. And there's the black one right there. So I'm going to twist these together. And I'm just going to solder these together right here, because I think that's going to make it easier so they don't accidentally come undone. Soldering iron is on. I don't have fume extraction, but I'm not expecting a lot of craziness, so we just got to be quick. Okay, so now those won't just suddenly fall off. All right, I'm just going to trim them up just a little bit. Okay. So now technically we have all of the connections that we need for this, but we do need to tie all of these together so we can make them common, tied in with that common, with the ground wire. So let's see what we got. Right, so the common from all of the switches are now tied together, and we're going to tie in this common as well. So I'm actually going to strip it so it's a little bit longer. All right, and let's just twist it into these bunch and tie it and solder it together. Excellent. So now all of these are soldered, or going to be soldered. It's going to take a little bit more heat because now it's thicker. But once they are soldered, it will make a much better connection. on these buttons, they actually came pigtailed with silicone wire, which I like, and I'm using Teflon wire, which I think is actually really nice for to work with, because the insulation just doesn't burn off at all. So let's go ahead and solder these. And first one I'm going to do is just this ground wire connection. I'm going to put it right on the very end, right over here. I'm actually going to tin this connection first, just because it's going to be the hardest for me to get to. And I'll just do all of them. While I'm in the vicinity. All right. And we will bend this in. We could put heat shrink. In this particular case, I am not. It's a preference in this particular scenario because nothing's going to be close enough to actually move. So let's see if we can make it so you can see this. But I'm going to try and heat it up from the back. Right, and then merge it in that way. All right. Did it go? Okay. So I do have a good cable joint there. It's difficult to see, but it is both solid, and I do see that it flowed all the way through, so it did get hot enough. So it's not a cold solder joint. All right, and now I'm going to just bring this one over. Since I did the far side on this side, I'm going to do the far side on this one as well. And see how, because everything's tinned, there's a lot less smoke and a lot less hassle. It's just kind of like gluing at that point. All right, before we get too far out there, right, because now technically we put a wire in our way-ish. Okay. I want to just finish up these three connections, or these two connections here. So first thing I'm going to do, I'm going to tin these two wires because they haven't been tinned yet. And trim them. And actually this one as well. Because they're a bit too long for where we're actually going to need to go with them. Oops. I think it's this one right here. There's nothing electrical in here, so, but it looks like it did fall in. It's having a tough time focusing. Okay. So we're going to do the white wire to this one arbitrarily. All right, we're going to do the green one to this one. Okay. Oops. We're going to do this one to here. Not sure why it says I have. Music playing, but I don't hear it here. Well, doesn't matter. So we got these 3 connections. Last connection here is just going to here. Let's trim this a little bit and make that connection. There we go. So those are our connections. We got the joystick all wired up. Now we just have these connections here. So what I'm going to do is, this is kind of thick wire, and I kind of just want to have a single pigtail coming out to connect to this connector right here, which I think is going to make connection a lot easier. But let's actually write down what the functions are and come up with a pinout, because we may just be able to just do this direct. I think it's thin enough to where if I do the connections, it's going to be pushing it. Let's change the gauge. So this is thicker gauge. So what I'm looking at is, see the solder cups here? If I keep it the same, the insulation and everything is just going to be a mess to solder. Whereas if I use the thinner gauge, the 22 gauge, it's actually going to go directly in there and not have an issue. So let's get 3 more colors. Assuming I have. I have at least 2 colors. And we can make a third. Alright. Hopefully it wasn't just a shot of my behind. Let's see. So I got these 3 additional colors, right? And we already have white in there. So what I'm going to do is just take a black Sharpie. I'm just going to put a band around the outside. Oh, which doesn't stick because it's Teflon. Great. Alright, I'm not going to do that because it's obviously not going to do anything useful. So let's see what we could do. Well, we'll have to figure that out. So what I'm going to do, though, is I'm going to cut these shorter. Strip them so that way we are ready to solder to them. And we could just do this as a separate bundle, and I think the fact that the colors aren't the same won't be an issue. Or the colors are the same won't be an issue. I like that. That's an elegant solution. All right, so I'm going to go like this, and these are going to get a heat shrink just because realistically they need it since they're an inline splice. Otherwise, they're going to short out against something. So what I'm doing is this, and I'm going to bend it back. I'm just going to bend it back and then put the heat shrink inline, and it shouldn't be an issue. Okay. And let's see. Right, so see, it goes like that, and then the heat shrink will go just right over top. And yes, I could get ones without the pigtails on them, but I actually thought that the connector that we're using was a bit bigger and would have been able to accept it. So, you know, we just got to make do. It's a one-off project. So if it doesn't always work out, that's okay. You know, no big problem with that. So let's pull out some heat shrink. This is 3:1. But let's find the right size. That's the closest. I think that'll fit. Let's try it. Oh, that's perfect. All right. So let me get a heat gun. Okay. And the big thing is I don't want to overheat the PVC or it'll start to distort. So just something to keep in mind is be careful of your enclosure. Right, I think that'll work. Now that those are all together and we know where they're going from and to, we can actually twist them into their own little tether. Perfect. Right, so now we got these two tethers, and they're going to run to the same connector on the edge here. So now that we got all of this set, right, so this is all done, we need to determine what our pinout is going to be. So let's write that down, because we're going to need it for the other side, obviously. So 2, 3, 4, 5, 6, and 7. And this is probably going to be too overexposed for white paper, but let's define it. So first off, which one's pin 1? Okay, there it is. So I don't think you have any chance of ever being able to see this. Let's see. You can kind of see it. So you see how it's 1, 2, 1, 2, 3, 4, 5, 6, and that's 7. See, is that accurate? Maybe not. What's that center one? Oh, that's 4. Okay. So it's 1, 2, 3, 4. No, 1, 2, 3, 4, 5, 6, 7. So it's right to left. It's left to right in this particular case. Right? So our center pin is 4. Our center pin is 4. So let's do pin 4 is going to be our positive voltage. So we'll do V plus, right? And then we'll do pin 3 as our ground. Pin 1 we'll do as X, pin 2 as Y. And then down here, B1, B2, and B3 for the buttons. Whatever, that's a B. So let's wire this up. So let's prep our cables. We're gonna stick them through the hole there. We're not gonna pre-tin them just because it's not gonna fit in the connector. And one thing that we don't have, but potentially would have been a cool thing, would be an actual light indicator indicating that it's plugged in and everything's powered on. So this particular controller doesn't need it, or doesn't have it. I would have needed either to give up a button, or I would have had to put an extra wire. Neither of which I did. So, you know, something to keep in mind. If it's your design and you're doing it, you can put whatever you want as well. All right, so we're gonna do pin 4 first, which is B+, which is our red pin, our red wire. Okay. Just so we get a length. Perfect. In this particular case, we're not heat shrinking these, although we could. And this is going, I can barely see this, so it's going to be probably just as bad to see on the camera. I may need to pull out a pair of solder hands in order to do this. Okay. That's one pin, but you didn't see it because it was out of focus. Right? But that's soldered. So that's our hot wire soldered. Okay? So now we can look at here and match everything up. I'm going to arbitrarily choose green as X. All right. 2 is our other. All right, let's just solder both of those right now. All right, so we have 1, 2. And then 3 is going to be our common wire, our ground. So let's get that set. I'm going to verify that that is 3. That is 3. Perfect. And now we just have 3 connections left. So we arbitrarily have button 1, 2, and 3. So let's say yellow, blue, white. All right, so yellow is going to be pin 5. All right, and then it goes down. Remember, 6 is on the right, and then 7 is over here. So if we're doing yellow, then blue, then white. So it'd be blue over here. All right, so right, and then our last connection is the white, which is the bottom button in this set. Now, the key thing with this is we didn't want to melt it since this is a plastic housing so that it wrecks everything. So I think we did accomplish that. And now we can screw it in. So pretty much we're doing the final assembly. So over here, I put the screws. And these are microscopic in size with microscopic size nuts. Okay. We're gonna fully attach this now. And we do have enough of the screws to actually get it so we can thread onto it. So I'm just gonna do them one at a time. Again, it doesn't have to be tight, just enough so we can make sure that it's not falling out, and then we'll go back through and retighten them once they're all on. As I will tell you this, we're probably gonna drop one of them. If I don't, I will be very surprised. And in fact, if I had tweezers, I would do it that way as well. But I do not, so I'm using the diagonal cutter approach. Nope. Just needed to catch enough. No. Right. so here's what I'm going to do. I'm going to back out the screw a little bit, hold it up on end, slide it over, and then be able to do it. All right. And again, these are microscopically tiny. So now I have it over top. I'm going to back it off once, and then, well, unless it unless it cross threads, then I'm going to back it off again. Okay. So that is now there. We have to do the same thing again. I know this is enthralling. I hope the music is still playing, because it's not playing. I don't even hear it anymore. But I do see the view meters going. So hopefully it's not just silence when I stop speaking, when my noise cancellation kicks in. So I think that would make this more brutal than it should be. Alright, but I got all four in. And I don't know that we're going to complete the assembly tonight. Because honestly, I might do the electronic, the other side of the electronics, which is just pretty much coming up with a couple headers and things like that, so I can just kind of sit and ponder about the mounting solution and decide what I'm going to do with that. Because if it is something, I may just build a board and just build a small box if that's kind of how it's going to be. So, and use a different box. So, it remains to be seen. I'm probably going to hold off on that until tomorrow. Or at least come up with a good interim solution so we can start programming. Okay. So I don't strip out these particular screws, just because I think it looks nice, I'm going to try and align them all the same way. Right? Just so they look a little bit nicer. Because I think that attention to detail makes a difference. Alright, so now we've got that done. I'm going to put the cap on it. Last thing we need to do is put the gasket in. And then we can bolt it back together. And it's done. So this just pretty much, the slot that's right here, this will slide in there. Right? Just like that. Just make sure the slot is clean. And that the gasket material is also clean. And you don't want to stretch out the gasket too much, but they generally give you extra. So, you know, if you leave it a bit thicker, it will have more compression, which means it'll be more likely to be watertight. But if it's not long enough, you just stretch it a little bit. You can kind of make up for differences in everything. All right, and when you get to the very end of it, you just cut it to length, and I usually like to work backwards, so I push it so it's very close together, and then I will smush them together. So it, you know, it makes a continuous thing, and then when you actually get everything compressed, you know, it's got this bead around the edge that will smush into there and compress it, and that's how it makes it. And you notice that the actual attachment screws to hold the lid closed are outside of the gasket, and that's because they go all the way through. So that's how they dealt with that. You know, technically, if you don't drill anything in here, it's a fully sealed box. So, you know, but I think this is good. So we got our connection here. Right, and I could put Loctite on there if it becomes an issue. We have our connection here, which is close but not an issue. We have our 3 buttons, which may need a little bit of sealant, but, you know, at the end of the day, I think that's fine. So we're just gonna twist this in a little bit. Okay. Close it up. Right, I think that all looks good. Nothing to short against anything. You know, and everything's neat. Same deal, don't screw all of them down all the way until you actually make sure you have all of them in. Otherwise, it's gonna misalign the case. And then once you do, you can just pretty much do it until they're tight. So I think that looks really nice. Right? So we got the connection up here. Close it up. This joystick control travels separately. And that will connect to, eventually, to the pan, tilt, and zoom remote head that we made through a Pi Pico. So, you know, I think that's going to be enough for for what we're doing for today. I'm going to keep working on it in the back end. I'm going to try and build that box, come up with the mount so this sits on top for the Pi Pico to sit in. That also just does a little bit of power conversion. I don't think that's going to stop us from writing the thing, but I definitely wanted to get this assembled. That way there was some way to actually control it. And I think that this form factor for the hand is actually really nice. So this connector here, I'm going to do the same kind of soldering thing that we did with this, but just using a network cable. And this will just pop on like that. It has an internal gasket, and then, you know, it's solid. And it's got a little push button lock, so that way that cable will not come out. And I'm going to make it the same on both ends. That way, it doesn't matter which end you plug it into, it will be straight through. And that just has the pins there. So I think that's going to be a really nice mechanism to be able to do it. And I like the joystick as it feels in the hand to give the precise kind of control of this head that we're looking for. So thanks for watching the stream today. If you made it all the way through this as a VOD, I definitely thank you. And, you know, be sure to comment down below. Let me know what you think if you like this kind of longer stream, or even if you're watching this right now. So if you like the video, be sure to hit that like button. And, you know, if you think there's somebody who will like this kind of content, be sure to share that with them. You know, I would appreciate it, and I hope they would appreciate it too. And if you haven't subscribed, please subscribe. It helps me out a lot with the algorithm. And, you know, don't forget to hit that notification bell. That way you know the next time we're getting extended. So until then, take care.